So for this lesson, I'm going to review some of the questions that you will find in the Topic 2, Cycle 2 Learn. You've done these problems for homework, and I wanted to just give you an answer key. So I will have go through two questions that are very basic, then go through two questions that are harder, and then do one where you're looking at force diagrams. Okay, so for the first one that we'll go through, you have Sally who has a car that accelerates 5 meters per second squared, and if the car has a mass of 1,000 kilograms, how much force does the car produce? So as always, we're going to underline our numbers and start identifying what we have. So our givens, in this case, are 5 meters per second squared, and this is a unit of, or a measurement of acceleration. The reason I know that is because of that square. I know that's acceleration. The next number I have is 1,000 kilograms. Okay, in that case, I know that this is mass because it tells me so. And I am looking right now for force. Okay, so my unknown is force. That is what I'm trying to solve. So the next part is the equation that I need to use. So when I look at all the equations we've used in the past, the one that best fits is force equals mass times acceleration. I have my mass, I have my acceleration, so I simply plug it into the formula. Force equals 1,000 kilograms times 5 meters per second squared, to give me an answer of 5,000 newtons. So that's my answer right there. Now keep in mind this is the net force. And that's going to be very important once we get to the more difficult ones. So that is a net force, meaning that is the difference between my applied and my frictional force. So let's try another one. For number 5, the mass of a falling rock. What is the mass of a falling rock if it produces a force of 147 newtons with an acceleration of 10 meters per second squared? Again, in this case, I identify my givens. In this case, I have 147 newtons. That is a unit of force. And keep in mind that is a unit of net force. I also have 10 meters per second squared. That is a measurement of acceleration. And my unknown is mass. I'm looking for mass. Again, I'm going to figure out what formula works for that. I have force, acceleration, mass is my unknown. This formula of F equals ma seems to fit perfectly since I have two of those variables. So my force is 147 newtons. Mass is unknown. And I have 10 meters per second squared being my acceleration. So to isolate my variable, I divide each side by 10 meters per second squared. These cancel out, and my mass is 14.7 kilograms. Okay, so these are sort of the very straightforward problems. These will be able to get you between a 7 and an 8. But now let's go for some of the more complicated problems, 16 and 17. So these here, again, it's always that you start with your givens. So I have a 400 Newton rightward applied force is used to drag a large box across the floor with a constant velocity of 6.5 meters per second, and the mass of the box is 92.7 kilograms. What is the frictional force? So I like to draw these when they get a little bit more complicated. So here's my box, and I'm saying that I have a rightward force, applied force. That means my Fn is a pushing force of 400 newtons. So that was incredibly important to look at in this picture. Oh gosh, yes, good. All right. Then The other piece of information I have that I can draw, I think is actually fine with what I have. So let's write down what I have. 400 newtons is not my net force. It is my normal force. There is a difference. That means I cannot use my F net equals M over A. But let's see if we have some other information. So we have that. The next part it tells me is I have a velocity of 60 meters per second. That is a velocity. That is going to be a couple of things that I'm going to notice. I'm looking for a second velocity, but I notice these key words here. Constant velocity. That means that my final velocity has to be exactly the same as my initial velocity because it's not changing. It's constant. So I do actually have two velocities here. Next thing is mass. Mass is 92.7 kilograms. All right. So I'm looking for my unknown. Is frictional force. Okay, so I'm looking for FF. I'm not looking for net. So with that said, let's see if I can work through this. So I do know that at this point, in terms of my force diagram, I have a force diagram that should look like this. This is where I just do my tag. Okay, and I have 400 newtons going to the right. These two are equal because the object is not moving up or down. And so now I am looking for my frictional force. Well, first of all, it says constant velocity, so I know that my force diagram has to be balanced. So if 400 newtons are moving this direction, how many newtons of force are moving that direction? 400. That's my frictional force. But let's say I wanted to actually calculate that. I could calculate that by going, okay, I know that F net equals M over A. I do have M. So I have 92.7 kilograms. And I'm going to times that by, watch this, 60 minus 60 meters per second is my acceleration over time. It doesn't even have time. What is that going to equal? That's going to equal a 0 meters per second squared acceleration. Anything times 0 means that my F net is 0 newtons. Okay? So if I know my F net, I know F net equals normal force, the difference between normal force and frictional force. If I know this should be 0, and 400 newtons is my normal force, what minus 400 is going to equal 0? Well, of course, 400. There you have your frictional force. So there are two ways of doing it. You can do it just purely by the force diagram, or you can actually do the calculation. Okay, let's do the next one of the hockey player. Again, it looks like he's accelerating, so we have an acceleration. We have the mass being 0.167 kilograms of the hockey puck. And it is from rest, so that's a key word because that tells me that my initial velocity is 0 meters per second. And then it travels to 50 meters per second. That's going to be a velocity of 50 meters per second. I also know that it took 0.0121 seconds to travel that, okay? Any other information that I have? Let's find out what we want. I want to know what is the force, the applied force. So my unknown is the normal force. Whenever it says applied, that's what I mean. Okay, so can I get that? Well, I know that F net equals MA. I also know that I have velocities here, so I know that I can do my acceleration calculation by taking final velocity minus initial velocity over time. What other piece of information do I need? Well, let's start, and I also know that F net equals my frictional force and my net force difference, okay? And it makes no difference how you write them. So in this case, I do hear that I have 0 frictional force. It says neglect frictional force, so I put F force as, 0 newtons. Okay, so I know this one already is 0 newtons. And we're going to make this absolute values here, so you should never get a negative number. So with that said, let's work through this here. So I know that I have 50 meters per second minus 0 meters per second over 0.0121 seconds. This is going to get my acceleration. When I punch that into the calculator, the acceleration is 4,132 meters per second squared. Okay, so that gets me to punch this into my F equals MA. So in that case, if I were to punch that into this formula, I have my mass being F net. My mass is right over here. There's my mass. So that's 0.167 times then my acceleration, which I have right over here, 4,132 newtons, should be kilograms, and my answer ends up being F net of 690.08 newtons, something like that. It's going to be around that. So now I know that my frictional force is 0. That means that my net force over here is 690 newtons, about that. So what does my normal force have to be? Well, my normal force has to be that minus 0, so 690 newtons, because 690 minus 0 will equal 690. There's my answer. Okay? So let's do one more, the last one, and that is being able to draw force diagrams, actually the last two, between two objects. So I have here an object A, has a mass of 10 kilograms. I'll just draw it like this. Object B has a mass of 30 kilograms. And it tells me that object A is pulled with a force of 10 newtons to the right. So we have a force of 10 newtons over here, and it has a force of 20 newtons, so I have to make that vector double as long, 20 newtons to the left. Object B has a force of, 10 newtons to the right. In this case, it has also a force of 20 newtons to the left. So you're noticing that the forces that are being pulled are the same, but the masses aren't the same. So I've created a force diagram. The only thing I need to do is create an FG and Fn, and we can make those be equal to each other just by putting a dash and Fn. All right, which one? So it says which shows the greatest acceleration regardless of it. And just looking at this and looking at common sense, I know that the greater the mass, the more force is required to accelerate that. So I would say this one, because it has a lower mass, has a greater acceleration because you need to have less force. So object A. What is the net force of each one of these? Each of these has a net force of 10 newtons because 20 newtons pulling to the left minus 10 newtons pulling to the right is a total of 10 newtons. And for these, both of these objects are moving, and I should say accelerating. Accelerating to the left. All right, last one. Let's look at this one. Same sort of questions. What is the overall movement of these? Which one will accelerate faster? And in this case, I would say object A here accelerates faster because it has a net force of 4. How do I know that? Because there's 0 force on this side and 4 newtons of force on this side. Whereas this one has a net force of 2 newtons. So clearly this one is going to be moving, accelerating faster. This will be moving to the left,